Hi everyone, this is a video that accompanies my second A-Level Algebra worksheet, and it is all about expanding the brackets and factorising. Just like with the indices and surds worksheet, there isn't anything particularly new in this section. You should have come across it at GCSE level. All we're doing is rejigging your memory and taking it up a notch. So the questions that you'll see will be a lot harder than what you've seen at GCSE level. Just as a note before we get into the video, when I'm talking about factorising, I'm not talking about factorising quadratics just yet. That will come in a later topic or worksheet. So just as a quick recap, expanding the brackets. This is all about rewriting an expression so that it doesn't have brackets in it any longer. Factorising is the complete opposite. So we're taking an expression and we are putting brackets into that expression where possible. Right, here is the worksheet that we're going to go through today. Let's kick things off by going over expanding brackets to begin with. Okay, when a question gives you an expression like these here in pink and asks you to expand the brackets, what it means is you need to rewrite these expressions without brackets. These expressions without brackets are given in green. Okay, so you know what expanding brackets means, but how do you go about it? Well, hopefully you should know from GCSE how to do this. To rid an expression of brackets, you have to multiply everything inside the bracket by the thing that's immediately outside of the bracket. So if we look down here, we have x squared plus xy plus 2 inside the bracket, i.e. we've got 3 terms inside of this bracket. And we have x on the outside of the bracket. So to expand this bracket here, what you have to do is you have to take this x on the outside and multiply it by everything on the inside of the bracket. When I do this, I like to draw these lines to help me guide me through each step and also to make sure I haven't missed any terms on the inside of the bracket. So what do? First thing we do to expand the bracket, we take this x and times it by x squared here. We then take the x and times it by xy, that's here. And then finally we take the x and times it by 2, that's here. This then simplifies to x cubed plus x squared y plus 2x. So we've gone from this expression here with brackets to this expression without brackets. These two equal each other, but obviously this one has brackets, this one doesn't. We've expanded the brackets. Okay, what if the term on the outside of the bracket isn't just a term with numbers and letters in? What if it's actually a bracket itself? Well, in essence, the rule that we've just gone over for expanding brackets still holds. Everything in one bracket must multiply everything in the other bracket. Again, if we look down here, I like to draw lines to show me what I need to do. I need to take every term in this bracket and times it by every term in that bracket. So here, x must multiply 3x, so we get this here, and x must multiply minus 2y, so we get this here. We also have an a in this bracket, so a must multiply 3x, so we get this, and a must multiply minus 2y, so we get this. By doing this, everything in here has multiplied everything in here. And we get this, which then rewrites or simplifies to this expression here. This expression is equal to this one, but this one has brackets, this one doesn't. This is the expanded bracket version of this guy. So this example, or the method for doing this, can it be extended further? Like if you had more than 2 brackets, if you had 3 brackets, 4 brackets, blah, blah, blah. The same method holds. So in this example, we have 3 brackets, all containing x plus 1. You use the same method that you did here, but with one key difference. Take your time and do one bracket expansion at a time. So for instance, with this question, start off by sorting out the pink 2 brackets first, which yields this expression here, and then move on to the 3rd bracket, which then reduces to this. Just like take your time with things because it helps you not get confused and also it stops you from making silly mistakes. Right, let's look through some examples. If you want to, now's a good point to probably pause the video and try out these, like test your knowledge if you want, and then you can come back to the video and watch me working through them, just as a thought. Okay, we have to expand and simplify this expression here. So we know from our rules that everything on the outside of the bracket must multiply everything on the inside. So this 2x squared must multiply these three terms in this bracket. Then this guy here is separate. This minus a must multiply these two terms. So 2x squared times by 3 gives this. 2x squared times by minus x gives this. 2x squared times by 5a gives this. And then we move on to this bracket. Minus a times by 4x squared gives this. And then minus a times by minus 8 gives this. And this simplifies further because if you see you have an a x squared term here and an a x squared term here. So you can do this 10 minus 4. And there we have it. There's the answer. We've expanded both of these brackets and simplified. Okay, this one next. We have got 1, 2, 3 steps of expansion and then possibly some simplifying. So again, take your time, one bracket expansion at a time. So the first bracket expansion we're going to do is this bracket and this bracket here. So there we go. We've done x times by 1 and then x times by minus x, 3 times by 1 and 3 times by minus x to get this bracket here. Now this does simplify because you've got x and then you've got minus 3x. So we can condense them before we continue moving on. This is a really good best practice. You should simplify first because it's going to help you out in the future when you do your next expansion. So there we go. Now we're ready to sort out these two brackets. And what I've done is I've taken this 7 and gone, right, 7 times minus x squared, there. 7 times by minus 2x, there. 7 times by 3, there. And then I've moved on to this minus x squared. So minus x squared times by minus x squared plus x to the 4. Minus x squared times by minus 2x, 2x cubed. And then minus x squared times by 3. There we go. Again, before we move on, can we simplify this? Are there any like-for-like terms? Yes, I think there are. We've got an x squared term here and an x squared term here, so they can be condensed down. Okay, perfect. Now we're ready to do the final bracket expansion, i.e. we're going to take this 2x and multiply it by everything in this bracket. And there we have it, it's written here. Now something I like to do as best practice is I like to write my terms in order of powers, i.e. I take the highest powered term, so x to the 5, and I put that first, and then I do x to the 4, x to the 3. So these two lines are the same, but I've kind of cleaned things up a bit here, but essentially that's the answer. Right, let's look at this one. Again, we've got two brackets. So this 1 over x is timesing everything in this bracket. And this minus 3 over 4 x squared is timesing everything in this bracket. So here we go. We've done 1 over x times by 2x squared. That's here. 1 over x times by 3. That's here. Then we've done minus 3 over 4x squared times by 4x. That's here. I've multiplied the 3 times 4, so we get 12x. And then we've done minus 3 over 4x squared times by minus 8, so plus 24 over 4x squared. Now we just need to simplify. So this 2x squared divided by x just becomes 2x. We still have the 3 over x. 12x over 4x squared reduces to 3x. And then 24 over 4x squared reduces to 6 over x squared. Plus 3 over x minus 3 over x, that goes to 0. So hopefully you can see that this is the final answer. Right, last one. A plus b plus c plus d squared. First thing to do, we get rid of this square and just write out two brackets. And then the next thing is to expand these brackets. Again, I think at this stage you should really use lines like this. So you're making sure that everything in this bracket is timesing by everything in this bracket. It's keeping you on track, making sure you don't miss anything. If you do that, then you get this. So you get a times a squared, a times b, ab, a times c, ac, blah, 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 blah. I'm not going to read it all out. And then what you can do, you can simplify these. So what I tend to do is, again, I write out the higher powered terms. So I'll take this a squared, b squared, c squared, d squared, and I'll write that out. And then I'll look for, right, similar terms. Well, you have AB and BA. Well, they're the same, so you can write that as 2AB. Again, AC and CA down there. You can have that as 2AC, etc. And so you get to this, which is the final expanded version and simplified. Right, that's expanding brackets. Let's move on to factorising. Okay, we've just spent a bunch of time going over how to get rid of brackets in an expression. Now we're going to reverse all that and talk about how to include brackets in an expression. That's what factorising is, to include brackets. Just as a note, I know I've already said it, this is just basic factorising, i.e. we're not going to go over how to factorise quadratics here. This will come in a separate video and worksheet. Okay, so to talk about factorising, it's good to actually go back and talk about expanding brackets. So remember, with expanding brackets, we were taking a number or letter that sat on the outside of a bracket and multiplying it by everything on the inside of the bracket. So just think about what this means. It means that every term in the expanded expression is some multiple of the number or letter or term that was on the outside of that bracket. So just looking at this top example and just this bracket here, 2x squared is on the outside of this bracket. When we expand this bracket here, this term is a multiple of 2x squared, this term is a multiple of 2x squared, and this term is a multiple of 2x squared, i.e. 2x squared occurs in each of these terms. It is a common factor in all of these terms. When you need to factorise an expression, you're looking for these common things, these common factors or things that occur in all these terms. You're looking at them and going, okay, what occurs in this, that occurs in this, that occurs in this? Well, that divides by 2, that divides by 2, and that divides by 2. Is there anything else? That divides by x squared, that divides by x squared, and so does that. So 2x squared is a common factor in all of these, and therefore it can be brought out, put on the outside of a bracket, i.e. it can be factorised. So let's just see this in practice. Take this expression here, 2x plus 4. If we want to factorise this expression, you need to look for either numbers or letters that occur in each term. Well, I can see that this term has a 2 in it, and I can also see that this term has a 2 in it because 4 is 2 times by 2. This means that 2 is a common factor for both of these terms. That is, I can divide this whole thing by 2 and put 2 on the outside of the bracket. And that's what I've done here. Putting 2 on the outside of the bracket and then dividing through by 2 results in this expression here. This is equal to this expression here. However, this is its factorised version. We have a 2 on the outside and an x plus 2 on the inside. And you can always check you've done it right. So what you can do is you can take this and expand the brackets, and you should get back to this expression here. So if we expand the brackets for this, we get 2x plus 4, which is equal to this. So you know you've gone right. Okay, let's look at another one. Let's look at this. So we have x squared plus x. Again, I'm looking for things that occur in each term. I'm looking for common factors. Well, I can see that this term has an x in it, and so does this term. Therefore, x is a common factor of both of these terms. So I can factorise this expression by putting it in a bracket and dividing it through by x and putting x on the outside. Simplifying that, you then get x times by bracketed x plus 1. And again, let's just check we're correct. Let's expand the brackets. X times by x is x squared. X times by 1 is x. So we have x squared plus x, which is equal to this. So we know we're correct. This is the factorised expression of this. And finally, let's look at this guy here. It needs to be factorised. So again, I'm banging on about it. You need to look for common factors. Well, I can see that 3 is a common factor of both terms. There's a 3 in this and there's a 3 in this because 9 is 3 times 3. Also, I can see that x squared is in this and x squared is in this. So I can pull out 3x squared, i.e. I can take this expression, put it in a bracket, divide it by 3x squared and put 3x squared on the outside. This then reduces down to 3x squared times by bracketed 1 plus 3x. This is the factorised expression of this guy. Now, just as a note, you didn't have to do 3x squared in one big swoop. You could have just seen, okay, right, first 3 occurs in both. So you could have taken your expression, divided by 3 and put a 3 on the outside and then simplified. You could have then looked at your factorised expression and gone, oh, hang on a minute, you can also take out x squared. And so you could have repeated, but then for x squared. So just so you know, you don't have to do everything in one big step. I just did it here because, well, I only have so much room on these worksheets. Okay, let's look through some examples again. You can always pause the video at this point and maybe try out these yourself, and then you can watch me going through it and check your workings and your answers to my workings and my answers. So first example, factorise this guy. So again, common factors. There's an x here, there's a y there, there's a z. I don't think there's any letters that are in every single, like one letter that's in every single term. So we're not pulling out any letters. What about numbers? Okay, we have a 4 here. 20 divides by 4 and 8 divides by 4. So I think we're going to pull out 4. And there we go. That's the factorised expression. We have 4 on the outside, 2x plus 5y plus z. And if you want to check my workings, you can always expand the bracket of this and make sure you get back to this expression. Okay, second example. So again, looking for common factors. Let's look at numbers first. Well, we have a 7. This is prime. We have an 11. This is prime. And then we have 14. Like, no, there's no common factors between these numbers. What about letters? This has a y. This has a y. And this has a y. Okay, right, we can pull out y. There we go. Y on the outside, and then we have 7x, 11yz, and 14xz. Again, expand this. Check I've done it right. I will make mistakes at some points. Do let me know when you see them. Next one, factorise 16x squared plus 6x squared. Okay, numbers first. We have a 6 here. 16 doesn't divide by 6, but 2 does. I think we can pull out a 2. Is there anything else? X occurs in here and x occurs in there. Okay, so we can pull out 2 and we can pull out x. First, let's pull out 2. So we get 8xy squared plus 3x squared. And now let's pull out the x. And there we go. That is the factorised expression. This is what I was saying down here about, you can pull out the 3 and then you can pull out the 2 if you want. That's what I've done here. I've reduced it into smaller steps. I've done the 2 and then I've done the x. Right, another one. 6x cubed y squared plus 12x squared y. Any number common factors? Well, yeah, 6 goes into that once and 6 goes into that twice. So I can pull out 6. Any letters? We've got x squared here. And x squared can be pulled out there. So we can pull out x squared and then we can pull out y as well. So let's do that. 6 comes out first. Then we pull out the x squared. Then we pull out the y. There you go. Okay, let's look at some slightly harder ones. Now, like we saw in expanding brackets up here, you don't always have to have one bracket. Like, you can factorise and have 2 brackets if you want. It's just sometimes it's harder to spot these, but I'm giving you a clue here actually. This is going to have 2 brackets. When you're factorising, it's almost like simplifying. You're going to write this in a simpler way. So you want to be factorising so that you're pulling out quite a lot of terms so that things in the brackets are quite small, like small powers, small numbers. So I could look and go, okay, B occurs in every term. Maybe I'll just pull out B. But then let's carry on looking. Okay, there's an A in that term, there's an A in that term. So those 2 terms, I could pull out A squared, and B, and then I could pull out some numbers. That reduces them down quite a lot. What about the other terms? Okay, yeah, this has a B and a C in it. So does this. I could pull out B, and I could also pull out C squared and some numbers. So what I might do is I might put this term and this term together and factorise it, and I might put this term and this term together and factorise it. So there they are written together, nicely laid out for me, and I can start the factorising process. So for these 2, I've first pulled out a 4, and for these 2, I've pulled out 3. Next, I've pulled out A squared from these 2, and I've pulled out B from these 2, and then finally, I've pulled out B from these 2, and I've pulled out C squared from these 2. And so we have this. So we sort of have this bracket here and this bracket here. It still looks messy, but I think it's a lot clearer than all of this. Final example. Sometimes you can even pull out entire brackets from certain expressions. So with this example, when you have a question and the examiner, they're a bit like sneaky with this. They might have, they've put an x plus 2 and they've put 2 plus x here. I say they, this is me. You'll go, all right, okay, x plus 2 in a bracket, also x plus 2 in a bracket. I think they're wanting me to pull out x plus 2 when I factorise. Well, we've got this guy. Oh, okay, we've got an x plus 2 there. Let's just write it out in brackets, like write this out in brackets and then see where we're going to go from there. So here we go. This is this written out, but I've put this x plus 2 in a bracket. I've reordered this so it looks like that one. And then I've just taken this squared and I've put it on the 3 and this. So you can see, well, we've got an x plus 2 there, we've got an x plus 2 there, and we've got an x plus 2 there. That means we can pull out these. This is, x plus 2 is a common factor. There we go. We've pulled out x plus 2. So we get a 1 where it was here. We just get 5 where it was there. And then here we're left with the minus 3 squared and just 1 bracketed x plus 2 rather than it squared. And this is what you get. And now you can simplify this. 1 plus 5 is 6, 3 squared is 9, and then x plus 2. And we can expand the bracket here and see if we can simplify further. This is the bracket expanded, and yeah, it does simplify. We have 6 minus 18. So we can write that as minus 12 minus 9x. And we can even factorise a little bit further. Minus 3 divides minus 12 and minus 3 divides minus 9. So we can pull out a minus 3 and there we go. Minus 3 has been taken out, so we're left with 3x plus 4 and then this x plus 2. Okay, that's the second A-Level Algebra worksheet. I hope you found it helpful. As I mentioned before, this worksheet can be found on my Instagram page. A link to this is in the description box below. Thanks for watching.